using the fundamental theorem of algebra. So what we're going to do is we're going to do a combo here. Now sometimes we may get lucky and the graphing calculator may do everything for us, but other times maybe not going to be quite so fortunate. So if you don't have hold of a graphing calculator right now, make sure you do grab one because it can make life very easy on you. And for those of you that have still been looking for either online or phone graphing calc apps that actually are helpful, I think I may have found a couple. So when we get done with this, I'll show you those as well. Yep, absolutely. Yeah, I was going to talk about a couple of those too here when we get done. Yeah, if you find apps that you like using that work on that, I'm good with that. So, okay, here is our deal. We are going to... I didn't realize I'd been yammering and I'd already hit record. That's kind of funny. We're going to go ahead and, whichever method you are using, we're going to go ahead and get this first. Yes, sir?
Okay, someone cleared my calculator and made it so like there's a window range.
Now, if I talk really fast, will it act like I got caught up with all of this? Okay, I'll have to go back and do one later. Well, heck. Okay, but thank you. I'm going to have some good bloopers on here for people to watch. This is great. Besides me banging my head the other day, and at least now we're recording the rest of this. Okay, now how are we going to go ahead and get x by itself? Before, we will need to, but what do I... Yeah. We're going to square root both sides, and nice catch. Here, the big things I have to remember are, first, I need to take an I out, of course, which will make this, and I'll go one step extra here. Remember, it's also going to be plus minus taking the square root of a quadratic, which is the one nice thing about using the quadratic formula. You won't tend to forget that. So here I've got positive and negative 7i. There's two answers. And x equals 1 from the graph. There's my third. And I'm done. So when I'm doing these, I like to pick up as many answers as I can from the graph. Sometimes I can get them all. Sometimes I may only get some. But luckily, since everybody not in this classroom right now missed number 1, number 3 is going to work similarly. So we can actually see how this works. So let's pull this back up. We'll get our next one rolling here. Oops. And again, always double check when you get to the end. Just make sure you typed in everything right. Nothing worse than doing all the work and then going, oh crap, I didn't do the right problem. Okay. So I look and I'm like, okay, let's see. How many zeros do I see? I see 1, I see 2, I see 3, I see 4, and I should have 4. Awesome. Now let's see if we're lucky enough that the chart gives us some of them. Oh, even better than that. The chart's giving us all of them. Because again, wherever there's a y value of 0, those x values are my intercepts. They're my zeros. And I got all 4 of them from the graph because they all happen to be real and they all happen to be whole numbers. So, hey, hey. Again, if it wasn't, we have an easy fix for that. And we're going to get some more practice with it anyway. But that's what we're up to on these. We're just kind of typing them in. And like I said, I'm going to get some of you other options on online graphing calculators and apps. I should ask all of you what apps you use, because you probably have apps that are better than the ones I'm finding. Bless you. All right. Make sure we're good. Bummer. I know there's supposed to be 4. I see 2. Are they both whole numbers? Yes. Okay. So I've got x equals -5 and -1. And I got those from the graph. So I have 2 of them. I need 2 more. So now here's where it gets a little more interesting. Now I can use either of those x values when I'm doing my synthetic division. And it doesn't matter which one I use first. I'll end up with the same answer at the end. So I'm just going to go ahead and use the -5 here. No holes, that's good. And as we do this, just a reminder, when I get to the end, I shouldn't have a remainder because this is supposed to be one of my factors. So if you do ever get a remainder at the end, go back and double check and see either I did some wrong math somewhere or it wasn't actually a factor at all. So I ended up with no remainder. That's a good thing. And again, pay attention to what degree your polynomial started with. Started at the 4th. So we're starting at the 3rd squared x constant term. But here's something new that we haven't run into. Because if you notice up above in the steps that we had, when it got to step 3, we haven't had this issue yet. Repeat these steps, use successive divisions to reduce the polynomial to a quadratic, to something that's x squared. Well, this isn't x squared, this is a cubic. It's x to the 3rd. So whichever value you didn't use before, I didn't use the -1, we're going to use that and we're going to synthetically divide this again. Now, it doesn't mean you go back to the original problem. This is now your problem you're working with. So I'm going to use the synthetic division on it and run through the process one more time. So drop my first value, multiply, and add down, multiply, and add down, multiply, and add down. And once I've done that, again, now I'm looking at this one here, so I started with a degree of 3, so I start one below that. And we're in a situation similar to what we were when we were in number 2 before. Because now I look and I'm like, oh, x squared plus 9 equals 0. And just like we did up there, we can subtract the 9. And as long as we remember our two important things here, which is that it's plus or minus whenever I'm taking the square root of a quadratic, and then I remember to pull my I out, there's 2 answers, there's 2 more answers. So I have 2 real and 2 imaginary, but it adds up to the 4 that I need. So there's lots of little things that can come in with these that can make life a little more interesting. You're like, there can't be too many more things you can throw at us here. Oh, you don't know the half of it. And again, if we hit something, you're like, wait a minute, what did you just do there? I mean, stop me, I beg of you. Because I want to make sure we hit one of each of the different types of situations that you could possibly run into. Just to make sure. 1, 2. Now, we've talked about this before. We'll see if we remember when we get here. All right, let's see here. I see one at -3. I'm not going to get the other one from here. Okay, we're going to have to get creative this time. Okay, so I've got -3 from the graph. So let me get this out of the way for a minute. We'll come back to that. So we're going to go back to synthetic. Drop that first term down. Again, just multiply and add. Multiply and add. Good that we don't get a remainder. We're not going to have to do it twice because we're starting with a cubic, So we come down 1 is to be 4x squared minus 4x plus 1. And again, at this point, I have options. I could just go ahead and plug this into the quadratic formula if I didn't want to mess around. I could attempt to factor it because maybe, just maybe, this factors out. But the question is, does it? Does this one factor out nice? What will it look like? 2x minus 1, 2x minus 1. Now here's where I've got to be careful, because you might look at this and say, well, it's the same thing. So x equals 1/2, but I've only got 2 answers. But remember, when we look at the graph of this, we talked before about if something bounces, it can have what's called a double root. That is what we're talking about with a bouncer. I've got that reflection off of the x-axis, and when at that particular value, you'll notice when we factored it, I get the same solution twice. So when I'm writing down my answers, it seems weird, but my 3 answers are -3, 1/2, and 1/2. But it's the same thing. I understand that. But that's because you have that double root bounce. So sometimes you may only find what you think are 2 answers, but you actually do have all 3. Okay, so look for that bounce. If you see the bounce, you're going to be 1 short of what you would think. So let's see. We've had some for the graph. We've had some where we can just solve the equation. We've had some that are factorable. Wonder what we've got left that we haven't run into yet. There must be something. All right, 1 more to get typed in on this side. And we'll do a little cleanup work here. I did have somebody ask earlier in the day, well, now I see there's a hole here. Do I have to fill the hole with 0? Nope. Not unless we end up having to do synthetic division. Then we'll have a hole. Make sure we're typed in well. And I see 2 solutions when I need 4. Drat. Okay, so I've got -4 and -2 from the graph. So similarly to what we did up in number 4, looks like we're going to have to do synthetic on this a couple of times. That's no big deal, though. So 1, -18, 12, 80. And again, the process here just runs the same. Bring it down, multiply, add. Multiply. Where should my 0 be? Okay. Just get done talking about having the 0 in there and we leave it. One of those things where I don't always prefer being the example of having to watch all of your... I'm sitting here going, something ain't right. I'd have found that out. That'd have been nice. When I'd have gotten to the end and had a remainder, I'd have been like, what's going wrong here? Be like, you're being a goof. Okay. So -4, -4. That's much better. All right. Negative times negative is positive. In real life, I need to give more time to let this dry. There is no time for this. There is mathematics to be done. That's better. No remainder. Okay. I'm going to have fun getting this squished all together, though. So again, I started with a degree of 4. I'm going to smash in my degree of 3 here. 2, 1, 0. But again, I have a cubic. I'm not getting sucked into this again. So I have to do this 1 more time, using whichever value I hadn't used of my x's before. But now I'm using my new polynomial, which doesn't have a hole. bring it down, multiply. That's better. So I'm like, okay, I've made it to my quadratic since I had a degree of 3 there. So I try to factor this guy. I find out I can't. Crap. So, all is not lost. I just must use the quadratic formula now. So we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. So I crank out all of this stuff beneath my radical. So I end up with 36, because again, I always remember to put parentheses when I'm putting in my squared terms. So 36 minus 40 would be the square root of negative 4. We've gotten to chat about this plenty today. That square root of negative 4 is 2i. Square root of 4 is 2, and pull the I out. And don't quit. If you get to this point and all 3 of your terms have something that's divisible in, like 2, 2 answers, 3 answers, 4 answers. And that's what we're shooting for here. So it may be factoring, it may be the quadratic, it may be an equation, shoot, it may just be from the graph, but we have to be able to play. But now we get to the easier part. At least I think it's the easier part. Writing the functions. They're going to give you the answers. We're going to write the polynomial. Okay, this ain't bad. Now here's the one thing I've got to remember when I'm here. Remember, zeros are coming from your binomial terms. For instance, when it says these zeros are here, those originally came from these 3 binomial terms. Because remember, you'd set each set of parentheses equal to 0 to find the 0. If I set this equal to 0, I'd add 2. I'd get 2. I'd set that equal to 0, I'd add 1. So basically, you're just taking the signs of the zeros and switching them to make your binomial terms. But don't leave it. Then you need to multiply this out. Highly suggest you do 2 at a time. If you want to be big and bold and brave and go for all 3, you go for it, but I won't be doing it. So I'd FOIL out the first pair. 2x, negative 1x is, oops. It's negative 3x. Negative times negative is positive. And then bring down that other one. And again, whichever route you want to go for this, I don't care. For a lot of you, again, it might be in your best interest to use some sort of a way of keeping all of this a little more organized. But if you're perfectly comfortable just mentally distributing that through, I say you go for it. But otherwise, we'll just do our distributing via this box, which kind of organizes our terms by degree for us, which is never a terrible thing. And then I just go ahead and write them in degree order from greatest to least. And I get my cubic, which would be true of a solution that had 3 zeros anyway. So the big thing when you're doing these is just being cautious and remembering, oh yeah, so since all my zeros are negative, it just means all of my binomial terms are going to be positive in this case. And then again, just take them 2 at a time. And if you want to do like a little 2x2 box for the first pair and then do a bigger one for the second, that's fine. But again, this would be one of those that I would expect to see some sort of work on. I wouldn't expect to just see this answer sitting there with that. That doesn't really go together. And all I would do is burn you on the quiz and the test anyway. So once that's multiplied out, and I get my cubic. Now even these can get a little bit of a twist, because occasionally, just like we did on the other side, we are going to get some imaginary solutions. And they always come, hence our note, in what are called complex conjugate pairs. Now we did this a little bit before when we were trying to get I out of the denominator of a fraction. All this means is, if you have a 0 that's I, negative I will also be a 0. Okay? If you have a 0 that's 3 plus 2I, you're also going to have a 0 that's 3 minus 2I. They won't tell you. They're just going to assume that, oh yeah, if it's I, it's switch the signs on them. So this is where it gets a little weird. Because you're like, okay, I've got x minus 8. I have x minus I. I have x plus I. When you're doing these, you want to work with the i's first. Don't intermix I with one of the other ones. It'll make life hard. So instead, I'm going to go ahead and I'm going to FOIL out this part first. So this will stay the same. And when I FOIL out this difference, I've got x squared. And I've got plus xi and minus xi, so they'll cancel. So basically I've got x squared plus, ixi minus ix minus I squared. I just want you to see where I'm coming up with this. The ix and the minus ix would cancel. And what's I squared equal again? Negative 1. So this is minus negative 1. Which makes that plus 1. Because I should have no i's left once I get done multiplying that out. And then I can either FOIL or box this back out. So if I do, I'd have x to the third minus 8x squared plus x minus 8. And I've got my cubic for my 1, 2, 3 answers. But whenever one of your zeros is I, you have to deal with that first. Now this is just flat nasty. You're like, why is this so nasty? Well, check this out. We haven't had a binomial term as a 0 before. So when I'm doing this, so this is a positive, so I'd have x, make sure I do this right. Yep. Minus 3 plus 2i. And then that also is a positive 3, so it'll be x minus 3 minus 2i. So let's do a little simplifying here. I'm going to go ahead, I'm going to distribute this through. The negative I'm going to distribute through, that is. So x minus 3 minus 2i. And again, it's not I squared, so I can't turn it into negative 1. It's 3 plus 2i. And this big ugly looking thing here at the end, these two trinomial terms, are what I'm going to want to deal with first. Yuck. This is going to be, I wouldn't wish distributing this upon anybody. But we got to do it. So 3 by 3 box, here we come. But you will be amazed at how quickly things start to disappear. You'll be like, oh, That's all that's going to become? Yeah, it's going to be awesome. So I start filling this box in. Shoot. And just keep plugging away because, like I said, you are going to be amazed at how much stuff disappears. And you're like, and this is even just part of the problem. This isn't even the whole problem. I know. So I said I'd double check all my stuff because it would be terrible to do something else and this is all messed up. So I'm like, okay, what actually is going to go away here? Plus and minus 2ix. Okay, they're gone. Plus and minus 6i. Okay, they're gone. And we said before that I squared equals -1. So -4 times -1 makes this +4. And then that goes away. And miraculously, all the x's are gone. You're like, yeah, but there's still stuff left. I realize this. So I'm looking and I'm going, okay, what am I exactly going to have left here? I got x squared minus 6x plus 13. Okay. So let's see. Let's do this. So I've got x squared, combine my like terms there, minus 6x plus, and again it's 13 because I got to add the 9 and the 4 together. But then I got the x plus 5 left. And this is going to be the end. So help me. There will be no more twists or turns. Everything will turn out nice and neat. Combine my like terms. Ooh. Not fun, but we got it done. So let's see. Just to be certain, I want to make sure, I don't want to put you through all of these. I don't think I'd have time to put you through every single one of them if I wanted to. So let's see. Because what it asks next is to graph on the calculator, sketch and explain to 5 through 8. I'm just going to write out 5 here so you don't have to go looking and just show you how this works. And you should be good. But again, make sure you pay attention at the bottom of the page to the directions that we're working with here. Because again, I like to tweak things sometimes. Okay, so there's my expression that I'm going to be playing with. So I'm going to get this typed in. Okay, now, what's being asked of us is state the number of positive real zeros, negative real zeros, and imaginary zeros of each function. So basically, what we're looking at here is, okay, how many answers total should there be? Okay, so there should be 3 answers. Now, what do we notice right now? How many am I going to be able to find in the calculator? 1. So when they're asking about positive and negative real zeros, well, let's see. That looks pretty darn positive to me. So in this case, you would have 1 positive 0 based on the graph. I'm not asking you to find it. I'm just saying to explain. I don't see any negative ones because there aren't any over here. But then I would have 2 that are imaginary. Because they have to add up to that 3. But that's the only type of thing I'm looking for on a question like that. So if you're ever asked just to find the numbers of them, that's what I mean. And I just wanted to make sure by doing one of those. But otherwise, just follow the directions that are down at the bottom here. And just a reminder, this would be, keep my numbers straight here, Homework check 13. And this will be our second assignment in there. Our first one was the work back from Tuesday. And then tomorrow you'll have some time to be able to work on this if you want to in class. There'll be a video going of the quiz preview, and we can get you all ready for that way. Oh yeah, and I forgot.